All right. Hopefully you got my message. I said I posted the answers. So I posted them just about 20 minutes ago or so. Does anybody need to see the answers, or was everybody able to check them? If you need to see them, I could pop them up real quick. All right, then. Any questions on the homework?
Can you do 12?
All right. I heard 12, and then I didn't hear the next one.
Number 7, please.
7. Got it. All right. So we'll start with number 7. We'll just go in order here. Number 7 says y is equal to the integral 2 radical x to 2 tan t dt. Okay. Whenever the x is on the bottom, you're going to negate. Okay. So when we take the derivative of both sides, okay, the derivative of y is dy dx or y prime, however you want to write that. Okay. So we get dy dx equals, we're going to negate. Okay. Because x is on the bottom. And now we're going to plug the square root of x into all of our variables. Okay, so I plug the square root of x into this and get tan radical t. And then I have to do the chain rule, the derivative of the square root of x. That's first semester stuff, which is 1 over 2 radical x. Okay, you need to memorize the derivative of square root of x. And from here, you could either leave your answer like this, or you can put the tangent stuff on top and just say negative tangent radical t. I mean, I meant x here, by the way. Sorry about that. So that should be an x, and then 2 radical x in your denominator. All right, number 12. I hit record, didn't I?
Yes, sir.
All right, just making sure. All right, so by the way, while I'm thinking of that, I did not post the video that I did on the test we took last week. I didn't post that yet because I had someone in 6th period that still needed to take the test, but they're done. So I'll be posting that at the end of today's period. All right, number 12. We have the y is equal to the integral from 2x plus 1 to 4x t squared dt. Okay, so the derivative dy dx is equal to, we're going to start here and plug 4x into this. Okay, so it's going to be 4x squared. Chain rule, the derivative of 4x is 4. Minus, we're going to plug 2x plus 1 into this and get 2x plus 1 squared. Chain rule, the derivative of 2x plus 1 is 2. And then it's just algebra, okay? 4x squared is 16x squared, and 16 times 4 is 56x squared. Here we'd have to FOIL first, so we get 4x squared plus 4x plus 1. Distribute the 2 in and get minus 8x squared. That just doesn't sound right, does it? Did I write the answer wrong? Oh, no, I just multiplied this wrong. That's what I did. 64. 16 times 4 is 64, not 56. Is that right? Yeah. Doesn't sound right. Let me just do this. That's 40 and 24. Yeah, it's 64. Okay. All right, I'm good now. All right, distribute that and get minus 8x. Distribute and get minus 2. Combine like terms. That's 64. So now you get 56 minus 8x minus 2. All right, we good on that? Sorry for the confusion.
Thank you.
Mr. Rasan, I had a quick question about 7.
Uh-huh.
Okay, so I know where you had it as a fraction. Could you just leave it as the expression above?
Yeah, you could leave it like that.
Okay.
And if it's multiple choice, okay, they probably are going to write it like this, and you don't have to obviously rewrite it. If it's multiple choice, at this point you just look at it, pick your answer choice, and you go on. But there's a big interpretation of how you can leave your answers as far as what you have to do. All you have to do is if it's multiple choice, make sure you pick the right one. Okay. So you do all your work wherever you decide to stop. If they didn't stop there, they kept going, or they stopped before you, then you just got to find your answer. But it really doesn't matter if it's free response, if you stopped here or if you stopped here. You can't stop here though.
Okay, that makes
Obviously.
sense.
You're welcome. All right. Anything else on the homework?
Could you do 8, please?
Number 8.
Or actually, I meant 9.
9. All right. So we have y equals the integral 3x to 8x t dt. Okay. So the derivative is equal to, plug 8x into this t. So I get 8x times chain rule. The derivative of 8x is 8. Minus plug 3x into that t. I get 3x times chain rule. The derivative of 3x is 3. And I get 64x minus 9x, which is 55x.
Can you do 4?
4. All right, so we're integrating from x to 2. Okay, so that's brings up an alarm. Okay, which means we're going backwards. So when the x is on the bottom, we're going to negate, and we're just going to plug an x in. That one's just plug x in. Oh, yeah, and then chain rule, derivative of x is 1. So that's it for that one. Okay, what I want you to keep in mind here is don't take anti-derivatives here of this, okay? We can't use the fundamental theorem of calculus part 2 says I don't need to take anti-derivatives. I can just do this, okay? If I'm going to take the antiderivative of any of these expressions on the inside, then I'm using the fundamental theorem of calculus part 1, and then I have to do f of b minus f of a. We're skipping the whole f of b minus f of a thing unless we have a chain rule here. All right, anything else?
Mr. Masson, on
Yes.
number 8, I have my sine and my cosine flipped. Is that fine?
That's fine because you're multiplying them.
Thank you.
Yep.
Can you do 11?
11 says y is equal to the integral 2x to x squared 1 over 2 plus e to the t dt. Okay. So our derivative is equal to, we're going to plug x squared in first to this t. So we're going to get 1 over 2 plus e to the x squared. Chain rule, the derivative of x squared is 2x. That's just going to go in our numerator. So 1 times 2x. Minus, now we're going to plug 2x into t. So it's 1 over 2 plus e to the 2x. Chain rule, the derivative of 2x is 2. That's going to go in my numerator. I'm just going to leave it like that for you, but obviously I just wrote 2x over that. We're not going to try to get a common denominator here, okay? We're not going to try to scrunch that fraction together or anything. You can't do anything with that. So you just leave it just like that. All right, anything else? All right, so what we did here today or yesterday was we used the fundamental theorem of calculus part 2, and we were doing it algebraically, okay? When we're given the actual function, we're given the integral, we do it algebraically, okay? There's 3 ways that the information can be presented to you. I've been saying this all year, okay? There's algebraically, there's graphically, and then there's numerically, which is usually a table. Okay, so today we're going to be basically looking at the same thing, except now we have a graph. Okay, we don't have a function, which sometimes makes it a little harder because obviously you can't use a calculator, anything like that. Okay, the key here is we have to be able to interpret what's been given to us. Okay, so in number 1 here, we have a graph, obviously, and it tells us that w of x is equal to the integral from 1 to x f of t dt. The graph of f of t is shown over here. Okay. First of all, before I go on to what this is the graph of, let me state this. When we're doing problems like this, whether it's algebraically or graphically or whatever, you need to understand that there are three things that we are looking for. We're either trying to find an area, a point, or a slope. Okay, an area, a point, or a slope.
Mr. Masan,
Yes,
these notes weren't posted on the Wednesday.
they are not posted.
No, sir.
Yeah.
I apologize for that. Do you want me to post them right now and then you can print them really quick? Or do you want to just watch me do this and then I'll print them and you can go back? You guys tell me what you want.
Can you post it now?
Yeah, I can post it now. Just give me 1 minute here. I
The
gotta
class
just,
is okay with that.
yeah, no, that's fine. Don't worry. This actually lesson is not very long and it's not gonna take me very long to do this. All right, I need to go into here. All right. I'm just gonna post the notes for now and then I'll post the assignment after I'm done with the lesson. Now's a good time to take a potty break if you need to. All right, now you get to see the inner workings of me, how I build my module. All right, why are we locked up here? There we go. All right. I hope I did this. Of course, I didn't save it as a PDF. If I don't save it post it as a PDF, is that a problem for you guys? Or does it need to be a PDF?
To print it, well, for me, I can
Yeah.
print it straight from my phone, like if it's a
Okay.
PDF, but if it's a doc, it takes me a little longer.
Okay, all right, give me a second to save this as a PDF then. We're getting there. So as we're sitting here waiting for me to do this, I'll just let you know that Bloomingdale Baseball won their first game of the year last night.
Yay.
And if you don't know Colby, who just entered our class this semester, he had a great game. He was the MVP by far. He's now in our first period.
Yeah.
Yay, Kobe. Mr. Clemson.
He is Mr. Clemson.
What happened?
All right, I'm almost done saving it as a PDF and then I'll be done posting it. We're getting there. Computer's just working a little slow today. All right, it is saved as a PDF. Now back into here. All right, they are now posted. So I'll give you like a minute to get that printed. And then figure out how to get back to my Zoom meeting here. I got too many tabs open. All right, can you guys see my screen?
Yes.
Yes,
Yes,
sir.
we can.
All right, does any, let me know if you need more time on printing that. If not, I'll go ahead and get started. All right, we're good. All right, so I'll start all over. All right, so when we're doing these problems, we're either looking for an area, a point, or a slope, okay? And then obviously when we're given a graph, the interpretation is a little harder. Okay, W of X is equal to this integral, for the integral from 1 to X, F of T dt. This is the graph of F of T. So I'm gonna write F of T, but it's also the graph of something else. Does anybody want to take a shot at what this is also the graph of? It has something to do with W.
W prime.
That is correct. This is W prime, okay? And that's going to come into play when we get down in here, okay? So if we are asked to find W of 1, okay, it's no different than going back to algebra and I say F of X is equal to X plus 1, find F of 2. You're just going to plug 2 into that function and you're going to get 3, okay? So if I am given W of X and I'm asked to find W of 1, I'm just saying W of 1 is equal to, and I'm going to plug a 1 into my X. So it's the integral from 1 to 1 F of T dt. This is finding an area, right? When I'm integrating, I'm finding an area, okay? An area, a point, or a slope is what I'm going to be looking for, okay? And what's the integral from 1 to 1? Doesn't matter what the function is. Anyone out there? Integral from 1 to 1.
0.
That is correct. All right, I saw someone did type it into the chat. All right, so now let's go on to B here. We're finding W of 4. W of 4 is equal to the integral from 1 to 4 F of T dt. So we're integrating from 1, which is this point right here, to 4, which is right here. We need that area, okay? Now, that's not a shape that we know the area of, okay? This is a 5-sided shape, right? 1, 2, 3, or 4-sided shape, but we don't know the area of this thing, okay? It is not a trapezoid because there are not opposite sides parallel. So what we have to do is we have to break this up into that triangle. And then now this little thing is a trapezoid over here, okay? So I'm just going to do the area of this triangle is 1/2, the height is 1, and the base is 1. Okay, that's this guy. And then this trapezoid right here, so we're going to add that, is 1/2. The height of the trapezoid, okay, the height is going this way, okay, this way, okay, because it's the perpendicular to the two bases, the two parallel sides, and that is a height of 2. And then the bases are, this base is 1, and this base is 2, so 1 plus 2. Sorry if that ran in there, you can't read that a little bit. All right, so this gives me 1/2. And this is what 3 times 2 is 6/2. So I get 7/2 or 3.5. All right, C, we're integrating, or we're finding W of -2, which means we're integrating from 1 to -2 F of T dt. What does it mean to do when the smaller number is on top? What is going to happen?
Negate.
Okay, it's going to be a negative area. Okay, but now pay attention to this. Okay, when I'm going backwards from 1 to -2, it's going to be negative. But in this particular problem, from 1 to -2 is all below the x-axis. So this area is negative, but then I'm negating that. And so I'm actually going back to being a positive answer on this one. Okay, so you got to make sure you're paying attention to where the area is as well as what the area is. Okay, so in all reality, it would look like this. We're negating because we're going backwards, and then it's going to be This is what, a triangle. So it's going to be negative 1/2. The base of this triangle is 1, 2, 3. And the height of this triangle is 2. And so these two negatives are going to cancel, and we're going to end up with a positive area. 3 times 2 is 6. Half of 6 is 3. All right, D, W of -4. Okay, so we're integrating from 1 to -4, f of t dt. So we're going from 1 to -4. So we have this triangle. Okay, we're just going to go ahead and write down that answer. The area of this triangle was 3. And now we're going from -2 to -4 the rest of the way. Okay, that's a trapezoid. But, okay, since we're going from -4 to 1, okay, or excuse me, yeah, from -4 to 1, okay, or in this case to -2, this is a positive area, but since we're going backwards, it's going to be a negative area. So it's minus this right here. And the area of this trapezoid is 1/2. The height is 2, and the bases are, this base is 1, and this base is 2. So we get 3 minus, that's 3 times 2 is 6, half of 6 is 3, and we end up with 0. So these two areas are actually the exact same area, and they cancel each other out and give us a total of 0. Okay, so once again, the hardest part of all of this is typically interpreting what the question is asking. If this is W of X, but it's the graph of W prime, because it's the graph of that function, and that is my derivative, right? Because the antiderivative of a derivative is this thing, okay? Then we have to decide if, are we looking for an area, point, or a slope? And when we're finding W of X, we're finding an area. Okay, now here, we're finding W prime. Well, this is the graph of W prime. So in W prime, I'm finding a point. Okay, so these are points. So W prime of X is equal to f of X, right? That just simply means, that's the fundamental theorem of calculus part 2. Plug this X into here and I get f of X. Okay, the derivative of this is, use the fundamental theorem of calculus part 2, plug in your X. Okay, if I'm asked to find W prime of 2, that's a point at 2. I'm at the point 1. Okay, W prime of -1, again, is a point. So at -1, I'm at the point -2. And I'm going to throw in one more question here on you, okay? And that question is going to be W double prime of 1. Okay. So if this is the graph of W prime and I'm asked to find W double prime, I'm looking for the slope at that point. Okay. So my point right here is 1. Obviously, we can't do this problem if this graph curves. Okay. That's why we usually typically get these graphs that have are piecewise lines. Okay. And the slope of this line is 1. All right. Are there any questions on that whole problem right there? Anything that we went over? Okay. So number 2 is same thing. All right. We're given the graph, or we're told that f is a continuous function, and this is the graph of f. Okay. Which is f of x. Okay. By the way, this is also f of x, right? I just wanted to point that out. Okay. All right, so we're given the graph of f of x, and this is also the graph of, excuse me, g prime. Okay, so, excuse me, I'm going to write that down. And we're given that integral, right? The integral from 0 to x. Okay, so this time we're integrating from 0 to x, not from 1 to x. All right, so g of -2 means, excuse me, a little dry today. All right, means to integrate from 0 to -2 f of t dt. All right, so we're going backwards, okay? We're going from 0 to -2, so we're going from right to left, which means we're going to negate, but that area that we're doing is negative, right? So this would be negative and then negative. This is a triangle. 1/2, the base is 2, and the height is 3. And so that's going to give us 1/2 of 6, which is 3. All right, B, we're doing g of 2. So we're integrating from 0 to 2 f of t dt. So this is, erase this out of here. We're doing just this rectangle right here. Okay, the area of a rectangle is the base times the height. So this case, it's 2 times 3, but we are negative because we're below the x-axis. And so the final answer is -6. All right, C, we're doing g of 8. So that is the integral from 0 to 8 f of t dt. So it's actually going to be this shape, and that is to 5 right there. I'm just going to label that's 5, but we're really going to here. So we also need this, okay, and this. All right, so first of all, this area is going to be negative because we're below the x-axis. So just put a negative sign here. And then this shape is a trapezoid. So it's 1/2 times the height of 3. And the sum of the bases, the first base is 5, and the second base is 2. And then plus this area is positive because we're above the x-axis, and that's a triangle. 1/2, and the base is 3, and the height is 3. What is that? 7 times 3 is 21. -21 halves plus 9 halves is -12 halves. And that's -6, right? All right, everybody with me? We good? All right, D is asking for a point because this is G prime. So G prime of 0 is -3. G prime of 5 is 0. And G prime of 8 is 3. And then the last one, they're asking for a slope. Okay, G double prime of 3 is the slope at the point 3. Okay, so that's this point. So we're looking for the slope of this line, which is 1. And I want to change this last question. I don't want G double prime of 6. I want G double prime of 1. G double prime of 6 is the same thing as G double prime of 3. But G double prime of 1 is this point, and the slope of this line is 0. All right, any questions? All right, guys, I'm going to post the homework right after we get off this meeting. If you have no questions, have a great day. And I'll see you tomorrow.